Today, we're on a quest, not for some long-lost treasure, but for something way more important, the future of how we power our planet. We're going to be exploring these incredible natural forces that could, one day, power everything. So let's dive right in. And we're starting with this massive question. What if our energy just never ran out? I mean, really think about that. A power source that just keeps refilling itself, day in, day out. It sounds a little like science fiction, right? But this exact idea is what's driving this whole global journey for new energy. To really get what this quest is about, you've got to understand the fundamental choice we're facing. On one side, you have the non-renewables, fossil fuels. Think of them like a tank of gas in your car. Once it's gone for good. But on the other side, you've got renewables. They're more like a river that just never ever stops flowing. You can use them again and again. And that one difference? Well, it changes absolutely everything. All right, so the first leg of our journey is going to take us to the classics. These are the big three, the ones you've probably heard of the most in the renewable energy world: the sun, the wind, and our rivers. First up is solar. And really, we're talking about tapping into the single most powerful and just unlimited resource we have, the sun. The idea is so simple, but it's brilliant. These panels just grab the energy from sunlight and turn it straight into power that we can use in our homes. And, it's a lot more versatile than you might think. A lot of people ask, does it still work when it's cloudy? And yeah, it absolutely does. It's capturing light, not just direct hot sunlight. So it's still making power, just not quite as much. And it's not only for electricity. That same energy can be used to directly heat things, like the water for your shower. Okay, so from the sun, our journey takes us to another one of nature's invisible forces: the wind. And just like sunshine, wind is a totally unlimited resource. The concept here is just beautifully simple. The wind pushes on these huge turbine blades, making them spin, and that spinning motion powers a generator that makes clean electricity. But, trying to catch the wind isn't always easy. For these turbines to really work well, you got to put them where the wind is the strongest and most reliable. We're talking remote hilltops or right along the coast. And this, of course, starts a real debate in a lot of places, weighing that need for clean energy against things like noise and, well, how it changes a beautiful view. Our third classic renewable source brings us to the incredible power of moving water. With hydroelectric power, we're using the immense energy of a river, usually by channeling it with a dam. And what's amazing about this is that the water itself isn't used up or polluted at all. It literally just passes through, spins some turbines, and keeps right on flowing downstream. But just like with wind, location is everything. Hydroelectric dams need a very specific setup. You need deep valleys that get a ton of rain. And let's be honest, building something that huge has a major impact. It completely changes the local ecosystem and the natural rhythm of the river itself. Okay, so we've covered the big three, but our quest is far from over. Now we're going to dive a little deeper and check out the massive amounts of energy that are hidden inside the Earth itself and in our oceans. These are really powerful, but you don't hear about them as much. So first, let's tap into the planet's own internal furnace with geothermal power. I mean, the name literally means Earth heat. Here's how it works. You pump super hot water up from deep underground. The second it hits the surface, it flashes into powerful steam. That steam then spins a turbine, and boom, electricity. Then that water cools down and gets sent right back into the Earth. The whole cycle is totally sustainable. So you're probably wondering, if it's that good, why don't we see these plants everywhere? Well, it's because that intense heat isn't close to the surface in most places. You have to be right on top of what they call a geologic hotspot, or where tectonic plates meet. Places like Iceland are absolutely perfect for this. So while it's an incredibly powerful source of energy, it's just not an option for most of the world. Now let's head out to the coast and talk about the power of the tides. We're talking about capturing the incredible energy in the constant rise and fall of the ocean. And there are basically two main ways we do this. On the one hand, you have a tidal barrage, which kind of works like a dam at a river's mouth. It traps water at high tide, then lets it out through turbines at low tide. And on the other hand, you've got tidal turbines. Think of them as underwater windmills, just sitting on the ocean floor, spinning with the currents. And why is this so powerful? Well, here's a fact that's just going to blow your mind. Water is more than 800 times denser than air. Just let that sink in for a second. That means that even a slow-moving ocean current is packing a ridiculous amount of energy. It's why these tidal turbines can be smaller and turn slower than wind turbines and still generate a ton of power. But the real superpower of tidal energy, it's how consistent it is. It is so predictable. And why is that? Because the tides are controlled by the moon's gravity. So unlike the sun, which can hide behind clouds, or the wind, which can just stop blowing, we know exactly when the tides will come in and go out, centuries from now. For someone managing a power grid, that kind of certainty is an absolute dream come true. Okay, so if it's so powerful and so predictable, why aren't we seeing these everywhere? Well, because tidal power has some huge hurdles. For starters, building this stuff is incredibly expensive. It also only works in very specific coastal spots. And you've got to deal with salty seawater, which just destroys machinery. Plus, the schedule of the tides doesn't always line up with when we all decide to flip on our lights and use the most energy. So, as we get further along in our quest, we start to see that the reality is a little more complicated. It's time to talk about the great renewable trade-off, the real-world challenges of making this clean energy transition happen. And this is where things can get a bit tricky. Take bioenergy, for example. That's fuel made from organic stuff, like crops. Now, since we can always grow more crops, it is technically renewable. But, and this is a really big but, it is not clean energy. When you burn these fuels, you're still releasing greenhouse gases into the atmosphere. It's such an important reminder that the words renewable and clean don't always mean the same thing. So when you take a step back and look at the whole picture, the central trade-off becomes crystal clear. On the one hand, the advantages are just massive, almost no greenhouse gas emissions, and an endless supply that nature gives us for free. But on the other hand, the disadvantages are just as real. They can be very expensive, they're limited to specific locations, and they have a pretty big visual and environmental impact right where they're built. And that brings our whole quest down to this one final, really important point. We've seen that every single one of these renewable sources is packed with incredible promise, but also comes with very real problems. There's no single silver bullet here. And that leaves us with the ultimate question. What is the right mix of all these different technologies to power our future? That's the next part of the quest, and it's one that we are all on together.